Hello, explorers, and welcome to Reach the World. For 25 years, Reach the World has inspired youth to become curious, confident, and compassionate global citizens, all through virtual exchange. My name is Tim, and I'm so glad you're joining us again for today's very special event. Today, we're climbing back aboard the scientific drilling ship JOIDES Resolution to join International Ocean Discovery Program's expedition number 400. Also known as the Northwest Greenland Glaciated Margin Expedition. The ship is currently off the northwest coast of Greenland in Baffin Bay, where the expedition team continues to conduct their research. And our friend explorer Michelle Pratt is aboard the ship and has taught us so much already about what the team has been up to over the past few weeks. If you haven't seen her Reach the World Virtual Exchange articles yet, be sure you head over to the link on your screen that I will share shortly after we're finished today and check that out. And today, remember, is our final opportunity to connect live with Michelle aboard the JOIDES Resolution. And as a special treat, we're gonna see something really cool today. Before we bring Michelle in, though, I want to also welcome the teachers and students who are joining us live today, especially our friends at Kittredge Magnet School in Georgia, who will be joining us on camera to ask Michelle their questions in just a little bit. If you're joining us via YouTube today, welcome. Please just remember, use the chat bar to let us know you're here. We want to hear from you, and also to share any questions you have for Michelle as we go. We will certainly work them into the conversation. But without further ado, I want to get Michelle on screen because she is ready to go today. Hi, Michelle.
Hi, Tim. Hi, Reach the World.
It is wonderful to see you, and I have previewed and hinted that we've got something really special in store for us today. I know you're right in the middle of it, so let's not waste any time. Let's get right into where you are today. Where are you?
Today, I am in the lab facility on the JOIDES Resolution. So as we talked about in our previous live events, the JOIDES really is a floating laboratory. So we do two main things here on the ship. First, we collect sediments, that is bringing them up out of the ocean floor. And then the second is we do some initial processing of those sedimentary cores. And that's here in the floating laboratory that is behind me. There's a lot of lab equipment on board and scientists of several different specialties and backgrounds. And we're going to meet some of them today.
That sounds so exciting. As we were preparing for this call, there was a special announcement over the loudspeaker. Can you tell us what that was and what it means?
Sure. So the announcement that happened right as you and I were getting connected today was the words "core on deck." And so that is the announcement that comes overhead on the speakers every time a fresh sediment core is coming up out of the ocean, and the drillers are ready to hand that off to the science techs and to the scientists here on board. And so it goes overhead because that's an alert to everyone on board who has a role in that initial receiving of the core sediment that it's time to get your hard hat, get your safety goggles, and come up to the core receiving deck so we can welcome that new core on board.
That is so exciting to be in the middle of it. It's the magic of virtual exchange, and you can, I believe, now show us exactly where that core would have come up into the ship, where it's coming up as we speak.
Absolutely. Let me get my safety equipment on here. And we'll head outside. I'm going to go to the core receiving deck where it's a little bit loud. There's a lot of fans out there that keep us warm. So I'll show you quickly out there and then come back inside and talk a bit more about it and describe what's happening out there. So first thing we have to do is go out these heavy marine doors. All right. And so what you'll see here that I've shown you before, whoops, that direction, the core comes right up here. So where my finger is pointing is the end of the catwalk, the core receiving deck area. Then the science techs lay the fresh core sediment here on these tracks. The core comes up in about 10-meter segments in plastic tubes that help to keep the core safe and eventually are the home for the core. So let me go back inside. Actually, let me show you this as well. Some Some people really like this. This is also a lot of the tools that many of the science techs use to help get some of that core sediment out. Sometimes it's really hard. Sometimes it's rock. Sometimes it's very compacted sediment or mud. And so it can be a little challenging to get out of some of the ends of the core barrels. And so here's some of the two tricks of the trade for scientists on board. Let me go back inside where it's not quite so loud and it'll be a little easier for you to hear. We're at, of course, very north latitude, so that noise out there, the heater fans that you hear, that help keep us
Michelle,
warm.
we just missed the core by just like 3 minutes, right? When just had come through that station you just showed us.
Yes.
All right.
Yep.
So it traveled the path you just walked from the drill area to the sampling area, and now where would you say you are?
Okay, so I just walked into the lab. So just to very briefly, there's a scientist behind me with the core section. We'll go see some more up close in just a minute. So once the core comes on deck, if it's a full 10-meter segment, then the science techs cut it into 1.5-meter segments so that it's a little easier to handle and process. And then we bring it into the lab. So would you like me to show you around?
I think I can speak for everyone here. We would love to see around. I'm fascinated to see where that core goes next.
I mean, that's why we're here, right? Is to check out a lab and see what a floating laboratory is and how things happen. So one of the first machines that the cores go through is this laser engraver machine. So like I was mentioning previously, science notebooks are really, really important. Keeping accurate scientific data is critical to being able to analyze these core sediments for years and years to come. So they get a physical label, like a sticky label, and with a QR code on it and some other identifying information, but they also get a laser engraved code on the side of them. So that helps scientists to keep track of those samples for years and years. And after that happens, then they come here to this rack and they take a break for a little bit. So they take a break because they need to warm up. So as you can imagine, these samples that come out of the ocean floor are very cold. We're at about 73 or 74 degrees north. And so they need to come up to room temperature. And we don't do anything to the samples to make that happen. It's just time. We just allow them to rest for a little bit. And while they're coming up to core temperature, there are a couple measurements that can be done while they're still in whole rounds. So here, let me actually use my hand to show you kind of about the diameter. The cores are about 6 centimeters in diameter. Oh, and I should mention that scientists generally use the metric system, so it's good to get to know that metric system. You can see my fingers wrapping around this core here, so you get an idea of the diameter. It's about 6 centimeters here. And so in whole rounds, they can go through a few machines over here. So this measures natural gamma radiation. And then some of the other instruments over on this side measure P waves, so like sound waves. They measure magnetic susceptibility. That's a big term for measuring the ability of the minerals to be magnetized, not whether they're magnetized or not, but just whether they can or cannot be magnetized. And all of those happen in whole rounds, and they can happen, some of these can happen still while they're cold. Often a question comes through about why we wait to warm them up. And this also has to do with a scientific principle. As the cores are warming, some of their physical properties can change slightly. And so it's important for scientists that they're taking measurements and observations consistently. So at a consistent temperature, that removes one variable. So it makes everything the same if they're always at the same temperature. Okay, and I'm going to pause for a breath and some questions here. This is what happens in whole rounds.
All right, Michelle, what a great introduction to the laboratory and the early processing of the lab core samples. I see that we've got a student from Mr. Gardner's class who may have a question for you. So if I'm interpreting that correctly, let's bring them on stage. Hello, good morning, Kittredge Magnet School. How are you? Great.
Hello.
This young lady in the front, if you have a question, please go ahead.
How guys drilled, and how many samples have you gotten?
Oh my gosh, we were just talking about this the other day. How many samples have we gotten? I think the number is between 400 and 500 samples.
Wow.
And yeah, it's a lot of samples. We have over 2,000 meters of samples on board right now, just from this expedition.
Oh my God.
Yeah.
Wow. Yeah, that is a lot. All right, great. Go ahead.
How long have you been drilling, and how long do you plan on drilling for?
Great question. So the JOIDES and several other ships similar to this that have worked in the International Ocean Discovery Program have been drilling for almost 50 years, 50. And on Expedition 400, though, we have not been drilling for almost 50 years. We've been drilling, we boarded the ship on August 13th, and we started drilling about a week later when we got to our first site. And actually, we're just on our last about 2 days of drilling. So I'm super glad that we have this tour going while we're still drilling.
Great question. Thank you so much for your question. Should we take one more from Kittredge? All right, go ahead.
Okay. So how do you guys know where you guys want to drill, and how you guys actually get to know where the minerals that you want to drill are?
That's an excellent question. Let's come on over here. Okay. So if we take a look at this map here, this is a profile image. So like this section is the ocean, and this is below the ocean floor. This image was taken via sound waves, and scientists call this a seismic image. So as they bounce sound waves into the ground, they reflect back and give scientists some information about the composition of those layers. So this entire map, whoops, it's been covered by a lot of other things. This entire map shows our drilling sites. Over here is the continent, so that's Greenland, and over here is off the continental shelf. And so you can see there's several labels here that show our proposed drill sites. And scientists take into account many factors when they're deciding what to drill for. The first and most important thing that they do is they start to analyze this map and determine what types of sediments they might want to cover or recover. So it's kind of like starting with a wish list. They mark this up with lots and lots of places that they would like to drill. Often they're looking at the sedimentary ages and layers, so like back to the Pleistocene, the Miocene, and they're determining what types they would like to recover. They start with their wish list, and then there are permits that they have to get. There's a certain number of days that we're allowed to operate, so they have to shorten their wish list into sites that we might actually be successful at drilling. So that is an awesome question about the process of science.
Excellent question. Kittredge, we'll come back to you after we continue our tour. Thank you for those wonderful questions. And Michelle, I'm going to bring in a question from the chat because I think it might be a great segue to the next part of our laboratory tour.
Perfect.
A student in Miss Stevens' class would like to know, let me see if I can bring it up. What information are you hoping to gather from these core samples?
That is a really great question. And the big question of why are we here and doing this work? So Greenland is covered by an ice sheet, as you may or may not be aware. There are 2 ice sheets left on our planet currently. One covers Antarctica and the other covers Greenland. And we do know that Earth's past has had different warming and cooling periods, but we don't know much about the behavior of Greenland's ice sheet. In fact, Baffin Bay, where we're at right now, is one of the least drilled sites on our planet. And so what we're recovering are some of the first recovered samples of these ancient layers of sedimentary deposits from glaciers over centuries and centuries. So you can see, I'm going to try to zoom in a little bit here because this is a really good example of the edge of an ice shelf. So the ice used to come out to the edge here of the continental shelf, and you can see these layers kind of go in a swooping fashion. These are glacial deposits over the years. So we're trying to recover these layers to learn more about Greenland's icy past, the warming trends that have happened in Greenland previously, and what that might tell us about the future. Absolutely awesome question.
All right. Thank you, Ms. Stevens' class. Thank you very much, Michelle. Why don't we pick up where we left off on our laboratory tour? What happens with those samples after they come to room temperature?
Perfect. So the next step after they come to room temperature, let's see if I can go in here. Yep, let me put my safety glasses on and I can come in here. Let's see if I can get in here. Okay. So after samples come to room temperature, then they are split in half. Yeah, do you mind, Doris, if I just zoom in on this? So this is a very freshly split core. So we divide them into two sections, and one is going to become the section that scientists will do a lot of samples on. We call that the working half. And then the other section becomes what we call our archive half. That's like putting core samples into the library, and we don't ever take samples out of that half. So maybe we'll stand here just a minute. I'm not sure if they're going to operate this saw or not. No. Okay. So we've got the freshly split halves, but here you see another half is ready and loaded, or another whole round is ready and loaded. There's a saw back in here that comes through and slices it halfway like a hot dog, and then we flip it open and bring it into the lab. So let's move into the lab.
That's so cool to see, Michelle, just the mechanics of getting the core samples ready to study further. Let me work in a question as you're moving.
Perfect.
Mr. Tomlinson's class would like to know how far you have had to travel to collect these core samples.
Oh my gosh. Okay, so the people who are on board have come from all over the world. So first we all took a flight to get to Reykjavik, Iceland. That's where we met the ship. And then from Reykjavik, Iceland, we had to sail 7 days around the southern part of Greenland and then up into Baffin Bay to our site locations. And now we're going to be done in a couple days, and we'll have to travel about 8 or 9 days to get back, because we'll be going into the wind and against the current on our way back. So it took quite a bit of effort, really, just to get here to collect these samples.
Okay, yeah, that's quite a journey. You've come a long way and gone through a lot of trouble to get these samples. They must be really, really valuable, provide some valuable information. And one more question before you continue with the tour. One of the students in Miss Owen's class saw a radioactive sign on the door when you came back in. Are their samples radioactive, or are radioactive materials used in these experiments or in the processing?
That is a really great question that I am not 100% sure that I totally have the answer. We do have a bunch of scientists on board. But let me say that if they're worried about us being exposed to radioactive material, that is not the case. The machines are all shielded and protected so that we're not being exposed to radioactive material. But let me continue with that question. We'll ask, I know there's some scientists on board who will have that answer for us.
All right, very good. Let's continue with our tour. Maybe the answer will reveal itself as we go.
Perfect. And actually, Tim, I wanted to mention, when you said that these samples must be really important, the work that has happened on the JOIDES Resolution and other ocean drilling ships for almost 50 years has revealed most of what we know about our Earth. So by drilling into these core sediments in the ocean floor, we're able to recover a lot about various different parts of the planet. So the work here, it really is important.
Absolutely. Great. Thanks for sharing that.
Of course.
Yeah, go. Do you want to pick up where we left off? What's the next step on the core processing schedule?
Perfect. Yes. So they've come in whole rounds. They've sat and warmed up, and then they've been split in half. Okay, so we're continuing along with the process of getting these core samples ready to work. And then they come into the lab. So I'll just give you a quick pan of the lab here. There's two halves to the lab. So over on this half is where the archive half goes. This is the library section, the part that we don't sample. But scientists do take some notes about the library half or the archive half. And then the other half comes to this sample table. And so you can see there's a few samples that have been taken. This is a very active working area. So what happens here is scientists take a look at the material. It's their first opportunity to really see what's inside these cores that we've pulled up. And different specialty scientists come and say whether they would like to take a sample or not. So there's scientists on board who are studying magnetism, and they will come and cut samples out of here to study the magnetic properties of the samples. There are scientists on board who study microfossils. So that's like kind of like big dinosaur fossils, but small little micro fossils. They come and take samples, and there are other samples that are taken to measure like the water content, the salinity, density, all sorts of action happens right here. And what's important about this is that this gives us a first opportunity to really understand what is happening with these samples. And we do this work right on board. We don't have to wait to get back to the labs to be able to do this initial work. We can get a first idea. So let me try and zoom in a little bit closer here so students can get a closer look at what some fresh sedimentary mud looks like.
Michelle, maybe I can share observation that some students might be having. When you were telling me that we were drilling holes in the bottom of the ocean and collecting sediment, I was expecting something that looked a little bit more like mud. And this doesn't really look like mud to me. It looks very dense and dark.
That is a really great question, and that'll segue to the next spot on our tour where scientists are describing what we're seeing. So let's hop on over here and see who is ready and willing to chat. Tracy. Hi. Do you have a second?
Sure.
Do you mind sharing here? Let me get over here. Do you mind sharing with students here? We've got a group of students who are learning about sedimentary mud, and they're really wondering what scientists do when we're doing the process of just observing what's in the mud. And Tim, can you let us know if the audio is good when Tracy starts talking?
Yeah, Tracy, just come a little
okay?
bit closer to the camera if you would.
Okay.
I can't hear you. So.
Oh, she can't hear you,
Yeah,
Tim.
otherwise
I can
good,
hear you.
Michelle. Otherwise good. Go ahead.
So there are a number of things we look for. We look at the color of the sediment because it can tell us something about the environment, whether it had a lot of oxygen or not a lot of oxygen. We look at the grain sizes of the sediment because the finer the sediment, the less energetic the environment would be. So when we're looking at deep green deposits like this, we expect to see a lot of fine grained material because it's being deposited in deep water below where storm activity can affect the seafloor, for example. And we also look for signs of life. So we look for fossils and even the traces of organisms that they leave behind in the sediment. So I don't know if you can show them.
I sure can.
Here, but maybe you can make out that there are a bunch of little squiggly looking things in there. Those are called burrows, and they're made by worms and other organisms that live on the seafloor, and they're burrowing down into the sediment to find food. And so we can look at the shapes of those burrows as well. So we document a whole bunch of things when we're looking at a sediment core. And you want
Sure. Okay, so we've been talking about science notebooks as well. And
Yeah.
Guess what? Real scientists use real science notebooks. Here we go.
So we have each one of these sections that you can see here is recorded on a separate sheet. So here we have a picture of the core, a scanned image. And then we document a number of different things like the grain size and the lithology. We look at the trace fossils. That is called bioturbation. And we document the level of bioturbation, whether it's really low, medium, or high. And then we look for sedimentary structures, tell us about currents acting on the sediment. Just take a series of notes describing the sediment, color,
That is so cool.
We probably filled in about 2,000 of these sheets now, if not more. Over the
2,000 sheets. Wow. Michelle, can I patch in a student at
Tracy's
Kittredge?
saying, I'm not sure if we cut out for a second, but Tracy is saying that they've completed about 2,000 of these sheets.
That is amazing.
Very
2,000 on
busy
this
work
expedition
doing
alone?
co-describing.
Is it, sorry, 2,000 on this expedition alone?
Can you hear me, Tim? Okay. I wasn't sure if the audio cut out there for a second.
Yeah. Can you hear me?
I can hear you. Yep.
Okay, great. I had a question for Tracy, and then I'd love to have a student ask Tracy a question if she's open to
Perfect.
it. We can sort of relay the audio, but is it 2,000 of those sheets alone on this expedition?
Is it 2,000 sheets alone on this expedition?
Yes, we've got
Ooh.
2,000 meters of sediment
Mm-hmm.
so far, and
Alright.
there's a piece for every meter. So, yeah.
All right. Well, I'm going to bring on our friends at Kittredge, and we have a young explorer ready for a question. Go ahead.
Does severe weather interfere with finding core samples?
Oh, great question. Does severe weather interfere with finding samples? It hasn't bothered us much on this expedition.
We've been lucky, but the ship. So we have you just tell them about how the coring works.
A little bit on the last
So
time.
there's
Last
a
time
big
we
pipe
did it.
that goes down the middle of the ship. There's a hole in the middle of the ship, and the pipe goes down through the middle. And the ship, if it gets really wavy, the ship just moves up and down around the pipe. So we're kind of
All right.
set up for bad weather.
Great question. Let's take another question from Kittredge. Go ahead.
When you're sawing through the core, has the saw ever gotten stuck into the core? And if yes, what does that mean about the core?
I didn't hear that.
Oh, the question is, have we ever gotten stuck in a hole?
No, sorry, Michelle.
yeah.
Michelle, the question is related to sawing the core in half. And does the saw ever get stuck on the core? And if so, what does it say about the content of the core?
Okay.
Ah,
I'm not the one sawing the cores open, but as far as I know, they haven't gotten stuck. We are getting some really hard rocks like granite and gneiss with the salt, and they have to use a special saw on them. And it takes a long time to get them off. Yeah. But for this stuff, it's pretty soft. Too long. That's one of the.
All right. Well, Tracy, thank you so much. It was great to meet you. And maybe before we let Tracy go, can Michelle, can you ask Tracy what her specialty is and how she got into doing this kind of work?
yeah. What's your area of scientific specialty, and how did you get into this?
Well, I'm a sedimentologist and a geochemist, right? Interested in what climate was like back in the past. And how did I get into it? Well, I had a really great high school teacher who taught me all about geology, and that really sparked my interest. And my family also did a lot of camping, so I was a lot and was just curious about how all the rock formations around me.
All right. Fantastic. Thank you. We have one more. It looks like we have one more question ready to go from Kittredge, and then we'll move on with the tour, Michelle.
Sounds great.
Oh, what do you find in the core?
What do we find in the core? Well, we find all sorts of interesting things here, mostly sediment, but we also find fossils, and we find rocks that have been carried out by icebergs, and then the ice melt out in the deeper water, and the rocks drop all the way down through the water and plop into the sediment, and we find those in the sediment. That's pretty cool. They're all different kinds of rocks.
Right. Can you maybe share one of the really interesting finds that you were super interested, that greenish mineral?
Oh, yeah.
Yeah.
There's also some interesting minerals we found. One is called Ikaite, which is a strange name, but it's named after a fjord in Greenland, actually. And it only forms when temperatures are close to freezing. and we found it in the core. So in old sediments, so it tells us that conditions were cold at certain times in the past. So that was pretty exciting. We don't have any in this core, unfortunately.
No, we don't have any in this core, but you were really excited when that was coming
super
up.
Excited.
Yeah.
I was geeking out.
All right, Tracy, it's so nice to meet you. Thank you for all that great information.
Of course.
Enjoy the tour.
All right, so I did want to come over here as well and show you one of the x-rays that we have up on the screen here. So one of the onboard instruments that we have available are x-ray machines. So for any students, if you've ever like broken a bone or gotten an x-ray from the doctor's office, you know that they can take pictures of what's inside of our bodies, even though we can't see that. So we have an x-ray machine on board that can take pictures or images of what's inside the cores. So while Tracy was describing that they visually look at the outside of the cores and describe what they visually see, the x-ray machine really helps them to see underneath the core surface. And I especially like the view of the bioturbation that Tracy was describing. So all of these little squiggly lines are burrows. And this is really important to tell scientists how much activity, how much life activity there was at different depths of sediment cores during different periods of time. And we can only see so much with our eyes on the surface. So this really helps to reveal what's happening under the surface. And that's really where the importance of a lot of the machinery on board comes into play, because it helps us take some initial analysis and understand what's happening with these sediments.
That is very neat to see, Michelle. And it brings up a question that I see in the chat that maybe you can address for us. Mr. Tomlinson's class is wondering, what's the most unique or unusual piece of equipment you've seen used as part of this expedition? I think x-rays on sediment cores is pretty cool. Is there anything more unique or unusual?
I'm trying to think. Let's see, is the schmizzle gonna run? Nice. Okay, let me see if I can show you this. So we have a couple instruments that take detailed pictures of cores. And this one here is affectionately known as the schmizzle. And let me get that, whoops, get that on your screen. Okay, we're gonna watch the schmizzle run over top of this core. And I think it's kind of cool because it kind of walks along the core. So it gets to the end and then it'll start walking along the core, taking high resolution images as it goes, and it's helping to analyze the color of the core. So we look at the color with our eyes, but then it also takes images of the color and helps us also understand a little bit more of the composition. So it's gone to the end and it'll come on back. That one I think is really interesting to watch it work.
Yeah, what a great live demonstration as well. Thank you for that. Fantastic. Another question from Mr. Tomlinson's class. Well, we have you, Michelle. We've met a couple scientists. We're seeing the heart of the scientific activity aboard the ship today in the laboratory, especially as there are samples to be processed. How many people are on the ship, and about how do they break down by job on the ship? Like how many people are scientists versus crew? It can be approximate.
That is a great question. I'm going to come into this lab space. It's a little quieter back here. There are 117 people on board. There are 27 scientists, or 25 scientists, 2 outreach officers, and then there's about 50 crew members. They're the people who run the ship, keep the engines going. They run all the drilling operations, which is super important because scientists can't do their work if we can't drill and bring the mud up on top. There are about 25 to 30 science techs who are also scientists, and like I've explained, their role is keeping the records and maintaining this big, huge library of sediment cores. And then we all like to eat and have a clean space, so there are people on board who cook and make some amazing food for us, as well as keep the ship nice and tidy and clean.
All right, fantastic. Thank you. And as a follow-up question from Mycroft, is the lab staffed and operated 24 hours a day?
Yes, it is. We work 24 hours a day, so each of us does 12-hour shifts. And yeah, we're running 24/7.
Very good. Michelle, if you are finished showing us the highlights of the lab, I think you were going to retreat to another room, and we've got a couple other things to show the students today.
Perfect.
As you're walking, what has been just an absolute highlight of this expedition for you so far? What's been your favorite thing?
That is an awesome question. I think one of my highlights is this environment, and we're between.
Oops. Shouldn't have asked Michelle a question as she's walking. Oh, now she's back. Okay, we've reestablished contact. Hi, Michelle.
It's always the stairwell, so I just walk quickly through it. Okay, let me get myself set up here. One of the highlights of the expedition for me has just really been being in this environment. We're between 72 and 74 degrees north during this expedition, which is further north than I've ever been in my life. And being able to witness gorgeous sunrises and sunsets, being able to be around icebergs. And for the most part, we haven't, icebergs haven't given us any trouble. We do have 2 ice navigators who are constantly watching them, monitoring them, and keeping us safe there. Yeah, there you go. We've had these gorgeous icebergs around us, which is a really good reminder of just how the sedimentary deposits arrived at the ocean floor and what we're bringing back up. So these have broken off of the Greenland ice sheet, and they're floating in Baffin Bay. And as Tracy was explaining, as they melt, they continue to drop little pebbles and debris into the ocean floor. But really just getting to witness these huge giants of icebergs and be in this environment has been a highlight of the tour for me specifically.
All right, great. We have not previously been able to show icebergs this well. So these are some pictures you took from the ship, and it must be so cool to see the process you were investigating, or the clues left by this process that's been going on for millions of years continuing to happen to this day.
Very much, yes.
Great. There is something on the desk in front of you that I know students are going to have some questions about. Let's talk about that for a minute, shall we?
Sure. So my nephews and their dad are really big into Lego. And so just right before the expedition left, there was a brand new release set, and it's the Arctic Explorer ship. So of course I had to bring the Arctic Explorer ship on board with me. And actually it's been super duper fun for scientists and crew on board as well. We've had a lot of fun making this ship, and then almost every day I come in, the scene has changed. So there's an orca that is part of the expedition, and currently the scuba diver and the crab are swimming on the orca's back. The lifeboat is dangling off the side of the crane. Here, let me put this up for you. So we've got a crane on board the ship, which actually we have 2 cranes on board the JOIDES. And so this is definitely representative of how things look here on the JOIDES. We've got our lifeboat dangling off to the side. We've got the bridge deck. And it's, for kids and adults alike, it's just been really fun. So, someone made a drilling derrick. That wasn't part of the original ship, but someone made a drilling derrick because that's how we roll here.
I'm glad to see that it's not all work, that there's some play happening as well. And we've got a young explorer in Kittredge Magnet School who looks ready to ask you a question. So I'm going to bring her on. Go ahead.
Does this help predict the changes in the ocean's current?
Yes, information that we're learning here on this expedition will help contribute to scientists' knowledge and ideas of how ocean currents may change as we continue to warm on our planet. Absolutely. Great question.
Very good. If we have another question, ask her. Oh, there she is. Go ahead.
So, where did you get the idea to dig? Just dig a hole. Where did you get the idea?
Right. So scientists have used these seismic maps, which are made from sound waves, and that gives them an idea of where the sedimentary layers are that people might want to recover. And then it's a big process of scientists deciding what the most important layers are to recover. We also have to get permission to be here. So the government of Denmark and Greenland has to give us permission to drill at these sites. And then we only have 2 months. So we have to fit everything that we want to do, all the drilling that we want to do, into that 2-month period of time.
Yeah, great question, Kittredge. I'm going to move you backstage just for a minute. We'll come back for more questions if there are some. But Michelle, you had an activity that you wanted to talk about, especially since we've learned so much about core samples today. If there are classrooms watching who are interested, can you tell us a little bit about this activity that I'm sharing the link for?
Yes, so for students who want to practice being a geologist and practice and learn a little bit more about how scientists do their work on board, there's a really fun lesson called Cores for Kids that has some guided worksheets, and you can take those and actually describe a core. There's some identification of microfossils, which are really important in learning the age of sediments. So kids, you can practice this, and teachers, it's a really fun and easy extension activity for exactly what we've learned about today.
All right, excellent. In the few minutes we have left, Michelle, time always goes so fast when we're talking together. Let's do sort of a rapid fire question and answer. I know you've got some answers to some past questions from students you wanted to work in. The answers you've done a little more research on and are ready to come back to them. But we have one quick question. Students noticed you're in a winter coat. What is the temperature there and how cold is the water?
Today I'm actually really warm. So the temperature today is about 1 or 2 degrees Celsius, which is anywhere from 34 to 37-ish degrees Fahrenheit. And the water temperature, though, is about 0 to 1 degree Celsius as well. So it's not actually that warm, but today I'm feeling warm, maybe because I've just been walking around and giving an exciting tour. But there's also no wind today, and wind can make a really big difference in how the temperature feels to our bodies.
For sure. You've got some people expressing their love of your Lego ship and your incorporation of Lego into the expedition. Question online. I'm just going to post it because it's very thoughtful scientific question. Are there any microbial bacterial samples ever taken from the sediment cores or evidence of their activity?
Ooh, that's really awesome. So yes, there are fossils, as they say in the last part of their question, but there are also sometimes organic material found in the sediment cores. And that also can tell us, if we're finding organic material, we can tell that there was previous life. So for example, say there was a leaf, maybe you found a fossilized leaf in a rock before, but say a leaf was embedded in the sediment core that came from Greenland. That can tell us a lot of information about whether or not there was organic material on Greenland in their past. Yeah.
All right, very cool. Michelle, do you want to address one or two of the questions from that have previously stumped us on live streams, but you now have some more information about?
Right. So one of the questions we've already answered, how much sediment have we drilled? So we've got that one covered. The other one, though, that was a question from Kittredge last time is what do we find in the sediment? We've talked a lot about that today as well, thankfully. Scientists talk a lot about sandy mud and muddy sand. So that refers to the composition of the sedimentary layers. We talked about bioturbation, so where little organisms like worms or other small critters have
crawled through the previous layers. Sometimes we found rock, so like granite, gneiss, and other different types of hard rock. And then Tracy also mentioned some of the really exciting minerals we've found. We've found some icaite, we've found some glauconite. And so it's really been a mix of material. And really that tells us that the sediment that's been coming off of Greenland in glaciers and then dropped as those icebergs melt, that tells us about the variety of what has been on land in Greenland.
All right, fantastic. Sounds good. I see another student ready with a question at Kittredge. Go ahead.
What did the cracks in the core tell us about the iceberg?
Ooh, what do the cracks in the core tell us about the iceberg? So there's two types of cracks. One is just as we're lifting and moving the sediment core, it cracks often, right? So those tell us nothing except that it just, in our handling of the cores, because it's in a flexible plastic tube, that it just cracks a little bit. But sometimes there are interesting layers that look sort of like cracks, but they can be layers of, say, sand, or, you know, an extra layer of bioturbated material. And that really tells us that something different happened at that time. So remember, we're drilling back in geologic time, right? And if we get to a point where there's something different happen, then scientists say, oh, I wonder what was happening in the climate at that period of time. And this is the evidence that scientists can use to support their knowledge of what was happening.
Great question. Do we have a final question from Kittredge today? Yes, we do. There he is. Go ahead.
How long does it take for one drilling sequence to happen?
Oh, that is a great question, and it totally depends. Let me use the Lego ship to show you. Okay. So the Lego ship, as Tracy mentioned, let me show you here. There's a hole in the ship, as Tracy mentioned, right? So we've got this hole in the middle of the ship, and we send the drill underneath the ship, And it depends how far we are down in the drilling process. So our deepest depth was 978 meters below seafloor. That means we have to travel a lot further distance to be able to recover that core. And that can take a couple hours. If we're just right at the sea level surface and we're only going through a shallow amount of seawater, it can be quite quick. Sometimes cores can come up in 30 minutes. Sometimes it also depends if we're trying to like grind through hard rock. That takes the drill a lot more work to grind through that hard rock. So that can be hours sometimes. And if we're just going through very soft layers, they can just send that drill down, bring up those soft layers very quickly. So it absolutely depends. Great question.
Fabulous question. Kittredge, you are all amazing. Thank you for the great questions today. I'm going to wave goodbye to you and move you backstage as we conclude our live stream. But thank you so much for joining today. The good news is we are going to talk to you some more, Michelle. Maybe not aboard the JOIDES Resolution, but you are winding down your expedition. We'll reconnect with you again soon to have your final reflections on the expedition and answer any remaining questions that students have. But I just want to say thank you again for joining. Thanks to all the teachers and students who joined us today. That tour of the laboratory was fantastic. And just remember, for everybody watching today, Michelle has written some amazing virtual exchange articles. I have put the link in the chat. And before I forget, let me put the link right up on your screen so that you all, if you haven't seen them yet, can be sure to go and see the articles she's written and the photos she shared that include some more details about the processes that we talked about today. More articles coming. We have a few more weeks to go on the virtual exchange. And of course, all of our recordings from past live stream events are on that expedition homepage too. So what a great chat, Michelle. Thank you so much. More to come. Stay tuned, everyone. Keep exploring. And Michelle, for now, I will say goodbye. Have a great rest of your day off the coast of Greenland.
Hey, as always, it's so much fun. Have a great day.
Bye.
Bye.